My name is Julian, and I'm an AI evangelist with AWS. Here we go. So why am I even talking to you this afternoon? Why does Amazon have anything to say about AI? Well, if you time travel to 1995, you would see on the very early Amazon website that we had a recommendation on that website very early on. It was obvious for Jeff Bezos, the founder of Amazon, that the e-commerce experience should involve personal content, personal recommendations, etc., etc. And, well, we hit the ground running. Last year, this research paper was published, and I highly recommend it if you are interested in recommendation problems. This covers the 2 decades of recommender systems at Amazon. And as you can see, the initial patent that Amazon filed on the recommendation system goes back to 1998. So we've truly been doing this for 20 years. And well, over the years, a number of domains within Amazon have been touched by artificial intelligence and machine learning. One of the most important areas is all the fulfillment centers, where the products are stored and where your orders are prepared. And today we have tens of thousands of robots moving autonomously inside the fulfillment centers to bring the shelves to the picking teams, the people who actually prepare your orders. And obviously this is based on AI for collision avoidance, route planning, etc., etc. This is another example of AI at work within Amazon, the Amazon Echo devices, and they use natural language processing, text-to-speech, speech-to-text, and the device itself is connected to AI services in the AWS cloud to perform all those complex tasks. Here's another example, and when this was first announced a while ago, people thought it was a joke. People thought it was an April's Fool kind of thing, but it's not. It's being tested today, and I'm talking about drone deliveries, right? So order something from Amazon and get a very fast drone delivery within just a few minutes, literally. So as you can imagine, this is AI-based. These are not remote controlled. They are autonomous drones. So again, route planning, collision avoidance, etc., image recognition, all this stuff is based on artificial intelligence. And well, I can't wait to see one of these in my garden. The last one I want to point out is Amazon Go. Amazon Go is a new shopping experience. It's open in Seattle. It's actually open to the general public. And as you can see here, you can literally walk in, pick something, and walk out. You don't have to pay for anything. You don't have to, well, you have to pay for something, of course. But you don't have to go, yeah, sorry about that. You have to pay. Unless you're French and you're trying to steal something, like I did, but I failed, so. But you're not going through a line, right? No cashier, no waiting times. Okay, so this works because on the ceiling of that shop, you have lots of tiny cameras that perform image and video recognition to see what you're picking and what you're putting in your basket. But when it comes to AWS, we're very proud that some AWS services are being used for those use cases. But our real mission is to bring the same capabilities to every single person out there, to all of you in the audience. So we want to put machine learning and data and deep learning in the hands of everybody, right? Give you the same tools as Amazon is using. And so over time, we built a machine learning stack with 3 layers, a high-level layer with application services, which are just one API call away. You don't need to do anything on machine learning specifically. You don't need to be a deep learning expert. Just call an API, get the job done. The second level is called the platform services, and these will let you train models and host models based on your own data sets, and you will have much more control over what you do here. And the lower level lets you pick infrastructure, CPU-based instances with the latest Intel chips, GPU-based instances with the latest NVIDIA chips to train and predict at scale. And of course, you'll be able to use every single deep learning tool out there. So we're going to go through all of this. Like I said, we have a lot of ground to cover. Based on this stack, we believe more AI and machine learning is built on AWS than anywhere else. If we look at the number of customer references that we simply have more, way more than everybody else out there. And well, it didn't fit on one slide, and I didn't want to leave any customers out. So, well, I had to put 2 slides, okay? And I'm afraid this list is going to grow. I will have to be more selective. And I hope to see your companies on that list pretty soon. These are just the public references, of course. So let's start talking about the application services, that high-level layer. The first one I want to talk about is called Amazon Recognition, and it's an image analysis service. So it's all in the name, right? Recognition is going to pick up visual content, and it's going to analyze it and provide you some information in different ways. The first one is object and scene detection, understand what's actually in the picture. The second one is facial analysis, find faces in pictures. The third one, face comparison, pretty self-explanatory. The next one is celebrity recognition, right? Recognize famous people. The next one is image moderation, detect suggestive or explicit content. And the latest, greatest feature in recognition is called text and image. So let's look at some examples. So object and scene detection is pretty much what you would expect. You send a picture to that recognition API, and it's going to give you some labels. And these are just a few of the labels you will get. Okay? You can get many more labels than this. And you get a confidence score. Okay? And that's all in real time. The image could be hosted in S3, or it could be passed in line to the API, right? And within a fraction of a second, you get that data back, okay? Actually, you get a JSON answer. All of those high-level services work with JSON, and so you just perform an API call and get a JSON document with that information. The second feature is facial analysis, so the ability to find faces in picture, okay? There could be many faces, as we will see. And we get some attributes, okay? So we get obviously the location of the face, the position of the landmarks, the eyes and the nose, etc., etc. And, gender, age range, emotion detection, glasses, sunglasses, beards, mustache, that kind of thing. Recently, we expanded the capability of recognition. Initially, it could only detect 15 faces. For latency reasons, and we improved that. And now we can detect up to 100 people in a single picture, again, in real time. This is a picture I took in India just last week, a workshop that I did on machine learning. And, well, as you can see, everybody's picked up, except my colleague, but you can't really see his full face, right? So that's a lesson right there. You have probably to see most of the face to actually detect it as a face. But everybody else is picked up correctly. And the dots that you see are actually part of the information that recognition sends on positions of the eyes, the nose, etc. Okay. Facial search, facial comparison is again a useful feature. Provide 2 images, and recognition will, based on the faces present in the first picture, compare them to all the faces present in the second picture and inform you about matches. Okay. And you can build face collections as well, so you could index millions of faces and again try to match a specific person into that collection, maybe for a security application or an online checking application, something that would save me some time at the airport maybe. Image moderation is important, especially if you have user-generated content and you want to make sure that people are not sending explicit or downright dirty content. So I'll stick to that one. If you want to try other pictures, feel free, but I'm not doing this on stage, right? You can find out how it works by yourself. But it's really important to have this feature. Manually moderating this is a very, very difficult task at scale. Celebrity recognition, you might know who she is, right? So you can detect famous people, actors, artists, sportsmen and sportswomen, politicians, etc., etc. We have a pretty large collection of famous people that you can actually recognize in the pictures. Text in image is the ability to find text strings in an image. Here, the license plate. And as you can see, we get a JSON answer with the position of the text. And if you have a longer text, if you have a sentence, you would get a bounding box for the words and for the full sentence. Okay? And this works pretty well. We can do a lot of different things with this, brand detection and generally extracting text. Here's an example of a customer that uses recognition for a really powerful application. They're called Marinus Analytics, and they build software for law enforcement, and this specific tool has been built to fight sex trafficking, and it's trying to find children that are been reported as missing. So building a face collection with all those kids, the law enforcement officers can then scan the internet and go to the ugliest places on the internet and collect pictures and try to match those pictures with the faces of the kids. And it works. When they put this in production on the first week, they started identifying kids, and they sent law enforcement to rescue them. So sometimes, AI can be a bit silly, just a bit, glittery, but you can actually use it for proper good, which is nice. A recognition video is a service we introduced at reInvent in December, and it basically extends recognition to video content. It could be either archives, right, video files that are stored in a S3, or it could be streams, right? Combining this with another new service called Kinesis Video Streams will let you perform video analysis in real time on video streams. Okay, so you can get the same features from recognition video. One extra thing that you get is activity detection, because since we have multiple pictures, we could say, for example, whether a person is running or falling, right? Which is something that's probably more difficult to do if you look at a single static picture. And we can do object tracking as well. So you can just try this in the AWS console. You can upload some video clips, and you will see that they get tagged with a variety of labels. And the orange blocks on top here show you where that sunset tag has been detected, right? Just that specific part of the video has this tag. You can also detect faces, and as you can see here, even fuzzy faces will be picked up, and we can track that face in the video. So for example, if this person appears, and here it does appear in two specific parts of the video, as you can see from the orange blocks, we're going to be able to figure out this is the same person, right? So we might not be able to figure out whether it's Gal Gadot or someone else, probably not in this case. Okay, it's an unknown person, so it's going to be called person 7. Okay, not very nice, but that's the best we can do. But still, we'll be able to figure out that this is the same person in those two clips. Applications here with the City of Orlando Police Department. Obviously, having a video system that lets you understand in real time what's happening on the street. And it could be, looking for missing people, looking for persons of interest, looking for all kinds of weird or unusual conditions happening on the street is an important capacity, and this is what the Orlando PD is doing with Amazon Recognition. Let's move on to Amazon Polly. Amazon Polly is a text-to-speech service, and well, it's a pretty simple one. So let me try and click on this thing.
Hejsan, jag heter Astrid och läser upp det som skrivs här.
Yeah, do you agree with that? Yeah. So Polly supports 25 different languages and 50 voices, and it's probably the easiest service to use. You just call that API to synthesize speech using the text string, using a voice, and again, in real time, you get a sound file that you can play, or that you can archive and play later in your applications. Okay? Very simple service to use. It's not just speech to text, it also supports SSML, which is a markup language that will let you specialize the way the speech is actually spoken. So here, we're going to use that prosody tag and listen to the result.
The price of this book is 45 euros.
Right? So I don't know how many shekels that really is. should try it. But you can specialize the intonation, the speed. You can customize the way numbers are spoken, phone numbers, room numbers for hotels, dates, etc., etc. So it's not just text to speech, sorry. It's also the ability to customize the way it's pronounced, and you can also customize the vocabulary. Duolingo is probably a company that you know. It's a super popular startup to learn new languages, and they found out that the quality of the voice that students listen to is very important in their progress. And that makes sense, right? Remember in high school, if your English teacher had a really, really bad accent, probably it wouldn't help you very much learn English or any other language. So same thing here. So, well, they did A/B tests involving Poly and other voice providers, and they found out in every single time that students learned better when Poly was the voice that they were listening to. So that's now what they're using. Let's move on to another service also announced at reInvent 2017, and this one is in preview, but you can join it. Please join it, test it, and send us feedback. So I don't think I have to explain what Amazon Translate does. It's a real-time translation service. It will detect language automatically, the source language, and it can translate from English to French, Spanish, Portuguese, German, Arabic, and simplified Chinese. And before you ask for Hebrew, no, I don't know when Hebrew is coming out. I'm sorry, but please join the preview and please ask for Hebrew and you will get it, right? That's the way. You have to yell at us and we'll build it, okay? And you're quite good at doing this, I think, right? Yeah, I've been to Israel before, okay? This is based on deep learning, actually, and in the later session, I will talk about the actual algorithm that is used for this. Who's using this? Well, people who have a large number of websites, for example, like hotels.com. They have a large number of websites in different languages. And can you imagine translated every single hotel page, every single customer review into different languages? I mean, you could extend that to e-commerce in general. It's a huge problem. At scale, it's just impossible. So using a system like Amazon Translate will let them automate a lot of the translation. And in some cases, they can just push that translation directly to the website because it's accurate enough. Another new service that was announced at reInvent 2017, also in preview, and you can also join that one. It's called Transcribe. So Transcribe is simply, it's the companion service to Poly, right? Poly is text-to-speech. Well, Transcribe is speech-to-text. So now you know how that works. Just provide a sound recording, and Transcribe will turn that into text. Okay, so today Transcribe supports English and Spanish, with more languages to come. It can figure out punctuation. It will give you not only the text, but also the timestamps, so you know exactly when that specific sentence was spoken. This could be useful for captioning, if you want to do automatic captioning, for example. Transcribe works with high-quality audio, but also low quality. It supports telephony audio, which is just, as you probably know, 8 kilohertz, very low bit rate. And this is a super important use case for call centers, right? People who want to automatically transcribe customer calls, customer interactions to text. Transcribe will be able to recognize multiple speakers as well, so not necessarily the voice, not tell you that Gal Gadot is talking to whoever, but it will tell you person 1, person 2, etc. An example of a customer using this, a company called Ring DNA. They build a platform, a communication platform for sales teams, and they have a number of tools in there just to help sales teams be more productive, just more efficient. And part of that is transcribing automatically all the phone calls. So you could have a phone call with a customer, or those guys could have a phone call between one another, and it's going to be archived and transcribed to text automatically, right? Which is good because you can then, of course, read it, or you could do analytics on that. and figure out if that customer interaction was a positive or a negative one, and do all kinds of useful things. They spoke about this use case at reInvent, and you can find out more at this URL. Another new text service, again announced at reInvent, called Comprehend. And we have a session this afternoon on Comprehend, so if you're interested in this, please hang around. So Comprehend is about natural language processing. It's about extracting information from text. So yeah, there are two ways you could use Comprehend. The first way is to use a single document. It could be a regular text document, or it could be an email, or it could be a tweet, or a Facebook post if you want to do sentiment analysis on social media. And Comprehend is going to extract entities, so the persons and the organizations that are mentioned inside of that document, some key phrases, so the important bits in there. The language is going to be detected automatically. We can reliably detect 100 different languages. And sentiment analysis is going to be extracted as well. Okay, so just again, one API call, and you get all of this done. Here's an example. Just pass in the AWS console. Just pass some text, and you can see, the pink stuff is people, and the dark blue stuff are organizations, etc., etc. Okay, and of course, if you call the API, you get a JSON document with all of this, and this is real time. The second way you can use Comprehend is topic modeling. So topic modeling is a technique that lets you build topics from a large document collection. So let's say you're a newspaper, right? The Washington Post actually uses this. So let's say you have thousands, maybe millions of documents, and you would like to organize them in topics. So that's what Comprehend is gonna help you with. Provide that library of documents in S3, tell Comprehend how many topics you want built, and Comprehend is going to run and automatically build a list of topics. A topic is going to be a list of words that are meaningful. So maybe the stock market topic will have words such as revenue, profits, quarter, CFO, that kind of thing. And maybe the Washington topic will have words like Trump, and Congress, and things like that, politics, and so on. Okay, so that list of words is going to be built automatically for each topic, and then Comprehend will score each document in the collection against those topics, right? And it's a small amount of data, even if the collection of documents is terabytes large. And then by using this information, you could say, well, now give me the top 10 documents that score more than 80% on the stock market topic, right? Or give me the documents that score the highest on machine learning and Washington. Not sure what that would be, but you never know. It could be interesting, right? Just an easy way to explore your data, much more efficient than full text searches. So this is the Comprehend console where you do that. It's probably the simplest console ever. Just point to your collection in S3, tell Comprehend how many topics you want, in this case 10, and just wait for a bit, and you will get the results. Very easy to use. A customer using this is Clearview Social. They build a platform that lets companies post stuff on social networks, or actually employees post stuff on social networks. So to optimize the impact of those posts, Clearview Social is using Comprehend to analyze the messages that are being posted, to extract entities and keywords, and it's going to tag automatically the messages with those keywords. And so this guarantees that you have the best tags possible, and obviously this is going to help optimize the impact and the shares of those posts. The last high-level service I'm going to talk about today is Amazon Lex. It's been out since reInvent 2016, and it lets you build chatbots. And in this context, a chatbot is going to be a conversation. So you're going to define, using natural language, the conversation that you want to have between the user and the application. You're going to define what we call slots, pieces of information that the bot should extract from the user. And once all the slots have been obtained, then you can fulfill the bot, you can actually perform the operation, book a flight, book a hotel, buy flowers, order a pizza, whatever. And this fulfillment will take place through a Lambda function that is hosted in the AWS cloud. Okay? So a chatbot is a combination of a conversation and a Lambda function. It's very easy to use. Of course, once you've built and deployed your chatbot behind an endpoint, you can integrate it with all your apps, mobile, web, etc., etc. And we'll even have connectors for enterprise apps. So instead of typing queries into your Salesforce or Marketo server, you could actually talk to it, right? Interesting thought. Liberty Mutual is one of our customers using Lex. It's an insurance company, and they built a chatbot that lets you ask for insurance quotes, actually car insurance quotes. So you could say, well, I'm considering this new car, and this is the make, this is the year, etc., etc. And in just a few seconds, you're going to get a quote from that, which is a very efficient way to interact with your customer, much better than going to a website. Again, they spoke at reInvent, last reInvent, so please watch their video for more. Now, these services are great. They're super easy to use. They've been trained on they've been trained on general purpose data, right? For voice and text and images, etc. But what if you need to work with your own data set? What if you have a more custom requirement? Maybe you want to recognize car parts, right, or mechanical parts. And recognition it's fair to say it's not going to do a good job at this because it doesn't know the specifics of those objects. Maybe you want to train a translation model. Maybe you want to translate Hebrew to Russian, let's say, and that's not part of Amazon Translate yet. Okay, maybe you have those more custom requirements, and in general, maybe you want to just dive deeper on the models and tweak everything. So the first of the platform services, and it has been around almost forever now, is obviously Amazon EMR, our managed environment for Hadoop and the Hadoop ecosystem. And this is very relevant for machine learning, specifically because of Spark, the Spark framework. It includes a library called MLlib, which has a whole bunch of machine learning applications, and it's very popular with data scientists and developers. So if you need to train at scale, if you already use Spark for ETL, for example, and you want to move to machine learning, Spark MLlib is actually a good option because you already know Spark. Okay? Zillow, you might know this company, it's a very popular US company. They estimate the price of houses. And they have a very, very efficient machine learning model to do this. And this is based on the ingest data with Kinesis, and then they clean it and predict it with Spark. Okay, so Hadoop and Spark are still relevant for machine learning. They're definitely not gone. But there's a new kid on the block. It's called Amazon SageMaker. We announced it at reInvent 2017. And I have another session this afternoon where I will dive much deeper on SageMaker. So for now, what is SageMaker? SageMaker is an end-to-end machine learning platform. It lets you go from experimentation in Jupyter notebooks to training at scale, even on very large data sets, hosting the model in SageMaker, and then deploying it at scale on fully managed web servers that will serve predictions to your applications. Okay? There is zero setup involved. You don't manage any infrastructure. Even if you train on 100 instances, even if you predict on 500 instances, you don't need to manage a single server, as we will see. It's quite flexible. You can use built-in algorithms, which are extremely scalable. They've been implemented by Amazon. You can use existing environments with MXNet, Gluon, TensorFlow, and more to come. So you don't have to install that stuff. Or you can bring your own container. You can actually bring your own prediction and training code hosted in a Docker container. So SageMaker will literally work with any kind of technology out there. And last but not least, you pay by the second, right? And it's a very cost-efficient way to run your machine learning jobs. So like I said, you have a combination of modules. You can work with notebook instances, so instances that come pre-installed with everything you need. all the tools that you need for data science, including Jupyter. But you don't have to use those. If you want to work locally in your own notebook, that's fine too. You can use the SageMaker SDK from your own machine if you want. Perfectly okay. We bring you some built-in algos, and actually my session will focus on those. You can also use, like I said, pre-built environments for Python, MXNet, TensorFlow, PyTorch, etc., etc. So no need to install anything. You can create your training infrastructure in just one API call. In preview right now, we have a feature called hyperparameter optimization. This basically uses machine learning to predict what parameters you should use for your training job. And we know that when we do machine learning and deep learning, coming up with the right set of parameters is quite difficult. It's a lot of guesstimate work, and we're trying to solve this problem as well for you. The preview is open, you can join it. And then once you have a working model, you can just deploy it to as many web servers as needed with just one API call. Okay, so you can use that full circle of modules, or you can just pick whatever you want, right? You could maybe train in SageMaker and deploy on-premise, or you could train on-premise and deploy in SageMaker, right? You don't have to go, you're not a prisoner of this circle, quite the contrary. You can literally pick what you want. Digital Globe is a customer that uses SageMaker. It's an interesting story. Digital Globe work in satellite imaging, right? So you can imagine they have a ton of data, and I really mean a ton. They actually have more than 100 petabytes. Yeah, let me say that again. 100 petabytes of storage in the AWS. So when you have that much storage, well, it's probably interesting to spend some time trying to optimize the cost, right? Of course, you could put everything in S3. Everything would be online, accessible, reliable, etc. But as it turns out, some parts of the globe are maybe less used by customers than others. So maybe they could go to colder storage, like Glacier. Okay, Glacier is our archive service where you move data from S3 to Glacier. You get much lower storage cost in exchange for, let's say, in general, 3-4 hours to get your data back. Okay, so you don't want to get that wrong. Okay, you want the hot stuff to stay in S3. You want the colder stuff to move to Glacier and save money. So they tried to figure this out by themselves. It was pretty challenging. So they talked to us, and actually they worked with an entity called the Machine Learning Lab. More on this in a minute. And using SageMaker, they built a machine learning model that can predict in which storage tier a specific map should go. And they built this successfully, and they estimate it's going to cut their storage cost by 50%, which when you have 100 petabytes, is quite a bit of money, I think. There's a nice blog post from their CTO that gives more information and more detail on how Digital Globe uses SageMaker. They also use it for map analysis, etc., at this reInvent video. So I just mentioned the ML Lab. The ML Lab is a team that we built to help companies who want to get into machine learning but maybe lack the expertise, and maybe they need external validation. Maybe they're afraid to waste time and resources chasing the right model, the right data, etc. So to help people get started, we built that team from experts working on the Echo device, on Alexa, on the Prime Air, the drones, on Amazon Go, right? So you get to talk to the people who actually build those exciting applications that I showed you at the start of the presentation. Okay, so get in touch if you're interested. We'd be happy to help. So now let's get to the lowest level of the ML stack. Okay, frameworks and infrastructure. Whoops. So they've been out for a few months now, but it's worth mentioning that we have a new GPU instance family called P3, and this lets you grab the latest NVIDIA GPUs on demand. I believe we're still the only major cloud offering them. And, well, the hardware statistics are crazy. right? So they are super fast, much faster than the previous generation of GPU instances and the P2 family. But ignoring hardware stats, they're just generally faster. Okay, so if you need to train on very, very large data sets, especially very large image data sets, very large models, and you've been using P2 before, I would strongly recommend that you try P3. It's quite likely you will get a very nice cost-performance improvement. Okay, and I want to mention, of course, that it's not just about GPUs. We also have the latest C5 family, which also has been out for a while. It's based on the Intel Skylake architecture, which is more of everything compared to the previous architecture, as usual with Intel. But these are specifically interesting for machine learning and deep learning because they have a new instruction set called AVX 512, and it's a vectorized instruction set that lets us run specifically linear algebra operations in parallel. And so generally, this is going to speed up your machine learning and deep learning processing. So, right, GPUs are nice. I love them dearly, but they may be a bit pricey sometimes. So do not discount the C5 instances. Usually, they may end up being the better option, actually. But you run your own benchmarks. What would you run on those? Well, I would again strongly recommend that you try the Deep Learning AMI, which is a pre-built AMI holding all the popular deep learning frameworks, TensorFlow, Keras, MXNet, and so on. All the data science tools that you probably need, all the Python tools, the Anaconda distribution, etc. You can manage multiple Conda environments to avoid dependency hell, etc. It's really, really a huge time saver. We have a lot of customers using this, and they move away from setting up their own instances and just fire up the deep learning AMI. It's free to use. You only pay for the underlying instance. So huge time saver. And well, we have this new thing coming out. It's called AWS Deep Lens. You can pre-order it from the Amazon.com website, and it's a bit of a developer toy, but yeah, I guess we have a lot of developers here, so let's talk about that. So Deep Lens, it's the first deep learning camera for developers, basically. We hate to brag, but a fact is a fact. So it's a collaboration with Intel, once again. It's running on Intel hardware. And what does it do? Well, you can train a deep learning image recognition model in the cloud, okay? And SageMaker would be a good place to do that. You can write a Lambda function in the cloud that's going to use that model to perform prediction, grab frames from the video feed, and run prediction on those, detecting people, objects, etc. This camera has obviously Wi-Fi, so using the Wi-Fi connection, you could, for example, send IoT messages back to AWS with the information that corresponds to the predictions that you took, right? So it's quite easy to use. It's running Ubuntu Linux, so you just power it up, register it in your AWS account, and within minutes you can start playing with some sample projects that we have, like face detection, object detection, dogs versus cats, and the mandatory hot dog, not hot dog project. If anybody wants to do hummus, not hummus, guys, I'm asking for help. All right, let's do that one. I'm so tired of hot dogs. And you can just start playing around. So what does it look like? Well, something like this, right? Something like this. So this is actually the object detection model. It will detect people as well, plus 19 other objects, okay? So as you can see on the left, the chair, the leftmost box is actually the chair. In the back, the sofa is correctly detected as a sofa. So then my son and myself are detected as persons, which is reassuring. I'm still a human person. And funny enough, my laptop screen is detected as a TV monitor, but that's close enough, right? There is no category for laptops in that model, so TV monitor is actually quite good. Okay, and well, you can just, that's what you would see on your TV, literally. You would plug deep lens into the TV, and you can see the original feed and the predicted feed. Yeah, it's a nice developer toy, okay? Have fun with it. And, well, when we put all those pieces together, this is the family picture, right? And like I said in the beginning, the only reason why we build this stuff is because we want to democratize AI. We do not want AI to be limited to very large companies, very large organizations who have a lot of resources, who have a lot of experts. And there's nothing wrong with that, right? There's nothing wrong with experts and big companies. But what about startups? What about developers? If one of you has a great idea for a mobile app and you want to use AI to make it even smarter, you should be able to do that, right? And maybe you're not a deep learning expert, and that's okay. You can use the high-level services. If you have a larger team of data scientists, maybe the problems are, just scaling the team. Not everybody's going to get a 4 GPU machine on their desk, right? If you are, I want to know where you're working. But that's probably not the case. Maybe you want to scale your infrastructure in general for training and prediction. And, this can be pretty difficult. So SageMaker is going to help you do that. And EMR is going to let you train, again, at scale on huge data sets. And if you want to go all the way down, if you really are an expert on deep learning and you want to use your own deep learning models, or you want to use pre-trained models, and you're a fan of TensorFlow, or you're a fan of PyTorch, or a fan of MXNet, then just pick an instance that you like, Intel-based or NVIDIA-based, and fire up the deep learning AMI and get to work in minutes. Okay? So we really want to put machine learning and AI into the hands of everybody. Okay? That's what I wanted to tell you today. I want to thank you very much. Toda. Thank you.